Everyone, I'm going to present my paper Learning Pairwise Preference from Movie Ratings. I'm Nurul from Bina Nusantara University, Jakarta, Indonesia. So this is my outline for today's presentations. I'm going to talk from the background and then related work, research method, and then result and analysis, and then finally I will conclude and show you my future work. Okay, I'll start with the background. People can express their reviews and ratings on some movies that have been watched. Like, for example, they can provide the reviews and ratings through IMDb, Rotten Tomatoes, and Metacritics. So it looks like this. So for example, we already watched this movie and then we giving them the rating and then some feedback. In a recommender system, there is a very important stage where we need to collect and querying preference of the users as part of interactive decision support system, which is called preference elicitations. Preference elicitation itself can be performed using many ways, which is explicit or implicit. Explicit through some feedback, ratings for some products or items. But with the implicit feedback, we can observe their preference through their browsing behaviors, history, clicks, etc. Using explicit feedback itself, such as rating only, has several drawbacks. Using ratings is very subjective. For example, there are two users with similar taste might give rating differently to the same item. A user also may not be consistent in giving number to express their preference. In other case, user may like an item more than the other item, but feel very difficult to give the lower rating on the other item because it means that the particular item is just as bad as the one that he or she does not like. In this case, often happen when the scale of rating is very limited. By showing two different items as a pair, so this is a new approach in preference elicitations, we can show the users the easier way for picking which one is the best, or both, if they like both equally. According to some studies, a task which aims to build a predictive model from the information about the collected user preferences is called preference learning. Currently, preference learning is divided into two approaches, pointwise versus pairwise. What is pointwise? Pointwise approach is like rating. So we giving out the number, exact number to the system, while pairwise approach showing a comparison of two items. The form of preference in pairwise choices is called preference relations. This representation is a useful alternative to absolute ratings for first, it can capture consistency across the users with similar taste. Second, preference relations is more natural way to express interest and become a direct input for top-end recommendations. Third, preference relations is easily be inferred from other implicitly feedback such as state time, page view, which has been collected through activity logs. The rating is important for people interested in this field. But the problem is that a movie itself can have a lot of features in it, such as director, actor, graphics quality, stories, durations, etc., which can make the ratings meaning become more complicated. Since we are interested in pairwise preference learning, in this study we transform the single pointwise ratings into pairwise preference. and evaluate the learning model based on several machine learning techniques. So, our contributions in this paper: first, pre-processing the movie ratings data into Pairwise formats which can be reused for other studies. Second, we built a predictive model to learn the user preference in Pairwise formats. And third, evaluate several machine learning techniques which best to predict the preference. This is some related work that we can mention. It's quite similar to our work, study by Liu, Zhao, and Yang in 2009, Randall from the Thaler, Gardner, and Smith team in 2009, Brun, Hamad, Buffett, and Boyer in 2010, Desarkar, Saxena, and Sarkar in 2012, and then my other work as well in 2017, 2019, and 2020. Also, Liu Xiaowu et al. In 2016. This is the research method that we use in this experiment. The dataset that we collected is from the IMDb website, which can be accessed on Kaggle. The dataset contains metadata of 5,043 movies released between 1916 and 2016. The data has 28 columns describing the movies, which consist of mixed data type, which is text, categorical, and numerical. And then we combine the datasets with the more complete scraped data published by Ronak Banik. We use the small datasets, which contain only 100,000 ratings from 700 users on 9,000 movies. So this is the description of our first datasets, and this is the description of our second datasets. So we combine both data into single datasets. How about the data pre-processing? We start with the data cleaning. In this step, we remove the missing values by dropping all the data points that has the missing values. When performing this step, there were 1,287 data points with missing value found. We dropped all this data and the remaining was 3,756 clean data. And then the second step is data transformations. We use label encoding algorithm, which performing the conversion from the categorical type into numerical. And then we also perform feature selection using Spearman's rank to measure the degree of nonlinear association between two numeric variables. So this is my data transformations using label encoding for content rating label. So this is one of our categorical data. We use simply encoding number. So for example, for content rating label approve, we give them encoding 0. For G general, we give the encoding 1. And then up to X rating, we give them 11. The feature selections, we only collect several features that has the highest Spearman's rank coefficients, higher than the other. And then we also we only consider these features in our learning. Data representations. We follow these steps. We separate the data for each user ID, and then for every user, we create a pairwise comparisons between the ratings. Then, we build the positive label data containing the pairs of data in the correct order. And then fourth, we build the negative label data containing the pairs of data of incorrect or opposite order. Basically, this is just changing the number sign. So this is our original data format with this rating as a point-based approach. And then we convert this original data format into pairwise data format. So for example, for user ID 1, this user give a particular movie rating 4, right? 1172. So this is 4, rating 4. And then he also give the rating for movie ID 1061, this one, as 3. So that's mean I can conclude that these users give rating movie with ID 1172 higher than the movie with the ID 1061. So I can see that 4 greater than 3. From these comparisons, I can build my positive label data by comparing the same attributes between these two movies. So user ID 1, actor Facebook likes is minus, the difference is minus 604. And then I give the label as 1 because 1 means positive. How about the negative label data? The negative data just because I want to show the different order, so I just change the sign of this number. So for the first row, I have minus 604. So for the opposite data, I have 604 with a plus sign. And then I give the label minus 1. So this is basically just a problem of binary classification. Okay, so this is the learning algorithm that I use. First is decision tree, an optimized version of C4.5. And then I also use random forest, which is built upon many decision tree which use as parallel estimator. And then support vector machine, multi-layer perceptron, k-nearest neighbor, and also naive bias. For the evaluation technique, in our experiment, the dataset is divided into training and test data. We use two types of data splits approach. First is holdout and then cross-validation technique. The holdout split point varied from 0.1 to 0.9 part of training set, and the rest we use it for testing set. The cross-validation technique divides the dataset into 10 chunks, then test them iteratively by picking out the different chunks as testing data every time. We applied the model to different users separately, and then the result for all users were average. So this is our result from the holdout method. We can see in the proportion of training samples from 0.1 up to 0.9. It clearly shown in here that the first winner is KNN, and then followed by random forest. And then the rest is just the same, similar, between the decision tree, SVM, multi-layer perceptron, and naive bias. And this is the result of our cross-validations method. The same as the holdout, so the winner is KNN, and followed by the random forest. So, to conclude our work, in this paper we already presented the preference learning by using pairwise datasets from movie ratings. Our experiment shows that KNN work best to learn this kind of data, followed by random forest. In the future, we plan to expand our work for different movie rating datasets, such as the ones from Rotten Tomatoes, Metacritic, and Movie Lens. We can also analyze the review given by other users to support the hypothesis. We also plan to use other approaches, such as logical-based machine learning, to show the users what is actually we learn from their preference. Okay, thank you very much for watching me. If you have any questions, feel free to contact me. Thank you.